Hello class 7 students, I hope you all are doing well. I am Monica Bajaj, your science teacher, and today we will discuss about your chapter number 4th, heat. In winters, we feel warm when we rub our palms continuously. Heat is produced due to the loss of the kinetic energy of the hands. When you hammer the nail, the head of the nail gets heated up. An invisible energy which causes the sensation of hot and cold is called heat. When a body is heated, the energy increases, and when it cools, the energy decreases. Heat is measured by the change in temperature. It produces metallic body. Unit of heat. There are two types of units of heats. Non-SI unit, calorie CAL, kilocalorie KCAL. These are order units of heat. SI unit is joule, J. This is the presently used standard unit of heat. Relationships. 1 kilojoule is equals to 1000 joules or 1 kJ is equals to 1000 J. 1 kilocalories is equals to 1000 calories or 1 kcal is equals to 1000 cal and 1 cal is equals to 4.184 J. 1 kilocalorie is equals to 1000 calorie, which means 1000 multiplied 4.184 is equals to 4184 joule. Temperature. While watching the weather bulletin, we often hear about the temperature of different places. The quantity temperature is a reliable method of finding out how hot or cold a body is. It is a measure of the degree of hotness or coldness of a body. The different units used for measuring temperature are degree Celsius, degree Fahrenheit and Kelvin. Here we will be using only degree C or degree F. The following formula shows the relation between the degree Celsius or degree Fahrenheit. Celsius upon 5 is equals to Fahrenheit minus 32 divided by 9. You can use the above formula to convert temperature from one unit to another. Example. Convert 98.6 degree Fahrenheit to Celsius. Now, let's see the solution. F is equals to 98.6 degree Fahrenheit. Now, C divided by 5 is equals to 98.6 degree Celsius minus 32 divided by 9. So, C is equals to 66.6 degree upon 9 multiplied by 5, which gives 37 degree Celsius. Now, let's see another example. Convert 40 degree Celsius to degree Fahrenheit. Let's see the solution. Celsius is equals to 40 degree Celsius. 40 upon 5 is equals to F minus 32 upon 9, which gives 40 divided by 5 multiplied 9 is equals to F minus 32. F is equals to 72 plus 32, which gives 104 degree Fahrenheit. Temperature scales. There are three temperature scales. These are Celsius scale, earlier called as centigrade scale, Fahrenheit scale, Kelvin or absolute scale. In common use, temperature is measured on the Celsius scale. Therefore, we will describe only Celsius scale. Celsius scale. The Celsius scale temperature was designed by Anders Celsius, 1701 to 1774. On this scale, temperature is described in degree Celsius. It is a metric scale of temperature. In this type of scale, we consider lower fixed point and upper fixed point. Lower fixed point is the temperature at which pure water freezes at the sea level to be 0 degree Celsius. The temperature at which pure water boils at the sea level is called the upper fixed point. It is taken as 100 degree Celsius. Divide the gap between them into 100 equal parts. Each part is equal to 1 degree. Thermometers. To measure the temperature of an object, we use a device called thermometer. There are different kinds of thermometer. However, the most commonly used thermometer are mercury thermometers used in laboratories and by doctors. The laboratory thermometer. A mercury thermometer commonly used in a laboratory is shown alongside. It consists of a thick-walled, fine-bore glass capillary tube. This capillary tube has a small thin bulb at its lower end. This bulb and a small portion of the capillary tube are filled with pure and dry mercury. Let's see an extra mile. Except for the doctor's thermometer, which is also a mercury thermometer, all thermometers are read keeping the mercury bulb in contact with the body, whose temperature is to be measured. The air in the portion of the tube above the mercury is removed by evacuation, and the upper end of the tube is then sealed. The portion of the capillary tube above the bulb, commonly called stem, is graduated in degree, usually from -°C to 110°C. Such a thermometer can be safely used for measuring temperature between 0°C and 100°C. Thus, the range of laboratory thermometer is taken as 0° to 100°C. On the Celsius scale, 0° is the temperature of the melting ice and 100° is the temperature of steam under the normal pressure conditions. How to use a laboratory thermometer? Before you start using a laboratory thermometer, we will give you a few tips to use it correctly. Follow the instructions for the proper use of a laboratory thermometer. Observe the calibration on the stem of the thermometer. Find out the value of one small division of the thermometer scale. It may be 1 degree or 0.5°C. Now suspend the thermometer from a stand with the help of a hook. Place a 100 ml beaker just below the thermometer. Pour tap water into the beaker such that the bulb of thermometer is completely dipped into the water. Observe the mercury thread in the thermometer. Read the temperature when it becomes steady, constant. Record it in your notebook. While reading temperature on the thermometer, your eyes should be at the level of mercury. Report your temperature as follows. Result: temperature of tap water is equals to -°C. Precautions to be observed while using a laboratory thermometer. While the temperature is being taken, the bulb of the thermometer should be kept vertically and in contact with the object whose temperature is to be measured. It should not touch the bottom or the sides of the container. The reading of temperature should be taken without removing the thermometer from its position. The eye of the observer and the mercury in the capillary tube should be at level. The thermometer should not be used measure temperature below its lowest marking or above its highest marking. Clinical thermometer. It is smaller in size with a temperature range from 35°C to 42°C. The corresponding marking in degree Fahrenheit are also usually marked on it. These thermometers are used for measuring human body temperature. The normal human body temperature is about 98.6°F. These thermometers have a kind of slight bend just above the bulb of the thermometer so as to stop the mercury from coming back into the bulb after the thermometer has been removed from the contact with the body. A clinical thermometer consists of a narrow glass capillary. It has a bulb at the end and it's sealed at the other end. As temperature rises, the mercury expands and moves up to show the temperature against the printed scale. How to use clinical thermometer? Before using, thermometer should be washed, preferably with an antiseptic solution, and dried using a cotton swab. Hold the thermometer firmly and give it a few jerks. The jerks will bring the level of mercury below 35°C. Now place the bulb of the thermometer under your tongue for about 2 minutes. take the chosen scale is called its temperature. Temperature of an object is measured with an instrument called thermometer. Precautions while reading a clinical thermometer. Wash the thermometer before and after use. Handle the thermometer with care to prevent breakage. Hold the thermometer horizontally, parallel to the floor at the eye level. Make sure the mercury level is below 35 degrees Celsius before use. Do not touch the bulb of the thermometer while reading it. Carefully see this table. This shows you the difference between clinical and laboratory thermometer. Clinical thermometer and laboratory thermometer. Clinical thermometer. It is smaller in size. Laboratory thermometer. It is larger in size. Clinical thermometer. The range of temperature allowed to be measured is 35 degrees Celsius to 42 degrees Celsius. Laboratory thermometer. The range of thermometer allowed to be measured generally minus 10 degrees Celsius to 110 degrees Celsius. Clinical thermometer. There is a constriction which does not allow mercury column to fall on its own. Laboratory thermometer. There is no such constriction. So, the mercury level fall as soon as it is taken out of the substance whose temperature is to be measured. Clinical thermometer. One needs to give 5 jerks to the mercury to make it fall for the next use. Laboratory thermometer. The mercury level falls to the room temperature on its own. Now, let's see the similarities between our laboratory thermometer and the clinical thermometer. Property, laboratory thermometer and clinical thermometer. Thermometric liquid. Laboratory thermometer have mercury. Clinical thermometer also have mercury. Scale of temperature. Laboratory thermometer Celsius and clinical thermometer Celsius. Transfer of heat. Heat flows from a body at higher temperature to a body at lower temperature. This flow occurs until both bodies have equal temperature. There are 3 different ways in which heat can be transferred from a body to another. These are conduction, convection and radiation. Let's discuss about conduction. Conduction is the process in which transfer of heat is possible through molecules to molecules from a hot to the cold end. The molecules themselves do not travel from one end to the other. The process of transmission of heat energy is solids without the actual movement of particular molecule from their position is called conduction. Explanation of conduction. In solids, the constituent particles are very closely packed. They can only vibrate about their mean position. When one end of a metallic strip or rod is heated, the particle at the end absorb energy and start vibrating more rapidly. These rapidly vibrating particles collide with their neighbors and transfer a part of heat energy to them. As a result, these particles also start vibrating more rapidly and in turn cause their neighbor to vibrate more rapidly. This process continues until the last particle also start vibrating more rapidly. Thus, heat energy is transferred from particles to particle through the whole length of the strip or rod. The process of conduction may be considered similar to passing of a book from person to person in a classroom. Condition for the conduction of heat. Heat can be conducted from one body to another only if they are first, contact with each other, second, at the different temperature. Good and bad conductors of heat. Materials which conduct heat rapidly are called good conductors of heat, and materials which do not conduct heat rapidly are called bad conductors or insulators of heat. All metals and their alloys are good conductors of heat. For example, copper, iron, brass, steel, silver, etc. are good conductors of heat. Glass, air, plastic, rubber, etc. are insulators. Most liquids are poor conductors of heat. Application of Good and bad conductors of heat. Uses of good conductors. Good conductors have their wide uses. First, cooking utensils are usually made up of material like copper and aluminium and alloys like brass and stainless steel because they are good conductors of heat. Second, boilers are often made with copper because copper is a good conductor of heat. Third, being a good conductor of heat, mercury is used as a thermometric liquid. Fourth, cooling coils of refrigerators and air conditioners are made up of copper as they easily conduct away the heat. Fifth, copper tubing is used in automobile radiators as they readily takes heat from hot water and coming from the side of the engine. Now let's see the uses of bad conductors. Like good conductors, bad conductors also have very useful in our daily life. First, the bottle saucepans are provided with wooden or ebonite handles. As wood and ebonite are poor conductors of heat, we can hold them with the objects are hot. Second, woolen clothes are comfortable in winter season. Woolen clothes have fine pores which are filled with air. Air and wool, being poor conductors of heat, protects the body from losing heat to the colder surroundings. Third, sawdust, being a bad conductor of heat, is used to cover ice blocks and prevent them from melting quickly. Fourth, a new quilt is warmer than the old one because a new quilt contains more air pockets. So it entraps more air and hence is a better insulator. Fifth, ice boxes, refrigerators have inner linings or glass wood which is very poor conductor of heat. This gently minimizes the chances of outside heat passing into them. Sixth, birds puff up their feathers in winters because in doing so they trap a large amount of air which in turn act as an insulators and does not allow the heat to flow out from their bodies. Convection. It is the mode of heat transferred among fluids. When a fluid, whether a liquid or a gas, is heated, its particles gain thermal energy, heat, which increases the kinetic energy. The increased kinetic energy increases frequency of collision among the particles. Every time the particles collide, they transfer the heat energy and the fluid becomes less denser with increasing volume. The fluid, after being less denser as lighter, rises up and be replaced by the cold heavier fluid. The cyclic movement of water during heat is called convection current. Air too is not a good conductor of heat. Being a gas, it can flow and spread fast and transfer heat by convection. Practical application of convection current. Ventilators. Rooms are provided with ventilators and exhaust fan near to the top of the side walls. The air we breathe out is warmer and hence lighter than ordinary air. It moves up in the room and escapes through the ventilators or exhaust fans. The fresh air enters the room through the windows and doors. It is cooler and takes the place of the warmer air, rising upward, and thus a convection current is set up. Land and sea breeze. Land and sea breeze near the coastal areas are a result of the convectional current set up in air. Since land surface is a better conductor of heat than water, it gets heated faster during the day. This makes the air close to the land surface warmer. The warmer air rises up and the cool air from the sea rushes to take its place. This gives rise to the sea breeze. At night, the land cools faster than water in the sea. So, the air above the sea is warmer than the air over the land surface. The warmer air over the sea, being lighter, rises up and cool air from the land take its place. These give rise to the land breeze. Next is ocean currents. The ocean water near the equator is heated by the sun to a much higher temperature than the water near the poles of the earth. This is because the sun rays fall almost normally in the equatorial regions but slantingly in the polar region. The ocean water in the equatorial region expands and become lighter, but the water in the polar region remain cold and heavy. Therefore, convection current of warm water flow on the surface of the ocean from equator towards the poles. Below the surface of the ocean, currents of cold water flow from the poles towards the equator. These currents are called the oceanic current. Radiation, direct transfer of heat from a hot body to a cold body having no contact between them and without the help of any medium is called radiation. In conductions and convection, heat transmitted by the particle in the medium. But in radiation, there is no need of medium particles. All the hot objects, whether they are solids, liquids or gases, can transfer heat by radiation, can occur even in vacuum. For example, heat is transmitted from the sun to the earth by the radiation. The sun radiated heat and this heat is called radiant heat. The amount of heat radiated by the hot body depends on, first, its temperature, second, its color and nature, dull or shiny, absorption of radiant heat. The quantity of heat absorbed by the body depends on its distance from the source of heat. A body closer to the source receives more heat than the farther from the source. That is the reason that inner planets are more warmer than the outer planets. Black bodies are better heat absorbers than the white bodies, as well as black bodies are better heat radiators than the white bodies. A brightly shining surface is a poor absorber of heat radiations because it affects the radiation falling on it. Okay class, let's quick revise with Reader's Digest. An invisible energy which causes the sensation of hot and cold is called heat. To measure the temperature of an object, we use a device called thermometer. Heat flows from a body at high temperature to a body at low temperature. Conduction is the process in which transfer of heat is possible through molecule to molecule from the hot to the cold end. Direct transfer of heat from a hot body to a cold body having no contact between them is called radiation. Okay class, we have done our chapter. Now it's time to take your leave. Bye. Take care.